Okay, so we'll now move on to our next topic, which is about two dimensions gihapon, but it is a special case of forces na applied for rigid bodies that are called as a two-force body or a three-force body. So ideally, from the name itself, this condition or this situation that when a body is being applied with two forces only, okay, o tulo ra pod ka force. Now, there is an alternative way to solve problems or analyze the force distribution of the body when two forces or three forces are the only forces that is being applied to the body, including its reaction, its applied force, or uh, its own weight. Okay? Now, there is a particular case of equilibrium, which is considerable interest, is that of a rigid body subjected to only two forces. Okay? Such a body is commonly called a two-force body. It will be shown that if a two-force body is in equilibrium, the two forces must have the same magnitude and the same line of action and opposite sense. Same ilang line of action, collinear with each other. And some ng mga example ani ng mga bodies that is being applied with force are those tension cables or links. Di ba? Duha ka points, aha siya supported, and then its tension force, that is the only force. Now, when it is in equilibrium, it is always uh, collinear ang ilahang line of action with the same magnitude but opposite ilahang sense of direction. Like for example, no, if a body at any form, if it is in equilibrium, their line of action must be parallel and collinear with each other, same magnitude and opposite sense, such that kaninga body, no? If you're going to sum up forces along x and y axis, there is a resultant or an excess force forming from these two forces if you add it together. Okay? And kani, no? If if their line of action is not collinear with each other, then it is said to be not in equilibrium. But if the force being applied to the body is collinear, same magnitude and same and opposite sense, if you're going to sum up their forces along the x or y axis, it will always be collinear with each other. And the no, abot lagi na sila. So here from this figure, if the plate is to be in equilibrium, the sum of the moments of force 1 and force 2 about any axis must be zero also. Diba? Kung imo siya ikuan, sum up og kag moment din niya, moment ka din ha, there is an excess moment, no, among these two forces at any point in the body. However, if we're going to sum up moment at A and at B, since collinear means sila, pila ilang perpendicular distance, it will always be zero. Given that it applies that the condition of equilibrium wherein the forces, summation of all forces, and summation of the moment of each two of these forces must be equal to zero. Ba? Because if we sum up moments about A, no, about this force, since the moment of F1 is obviously zero, the moment of F2 must also be zero, and the line of action of F2 must pass through A. And summing up moments about B, the line of action of F1 must pass through the line of action of B. No? Kana sila. Therefore, both forces have the same line of action. Ang kani ato ang line AB. Okay? For this force 1 and force 2. And from either of the equilibrium equations, summing up forces along x and y, it is seen that they must also have the same magnitude but opposite ilahang sense of direction. Zero pod ang moment. So kung zero ang force, zero ang moment, the body is said to be in equilibrium. Okay? So there is such a condition na ma-predict na to ang ato ang line of action of a force. Okay? Now, Another case of equilibrium that is of great interest is that of a three-force body. Tulupod ka buok. Okay? Such that a rigid body subjected to three forces or more generally, a rigid body subjected to forces acting at only 3 points. Tulo ka points. For example, upat ka forces. No, ang duha nag-act at 1 point. If you're going to determine its resultant force on that particular point because it is said to be concurrent, then pila ka buok forces ang mabilin. Kung atong isum up daan ang katong duha ka buok na nasa single point, tulo ra gyapon ka forces. Okay? So it is generally a body subjected to forces acting at only 3 points. Okay? Now, consider a rigid body subjected to a system of forces which can be reduced to three forces F2, F1, F1, F2, and F3, acting at A, B, and C respectively as shown in this figure. It will be shown that if the body is in equilibrium, the lines of action of the three forces must either be concurrent or parallel. Okay? So either concurrent or parallel. So there is a certain point wherein these three forces will intersect either within the body or at any point around the body. Okay? Since the rigid body is in equilibrium, okay, the sum of the moments of F1 and F2 and F3 about any axis must also be equal to 0. Let's take for an example, if you're going to sum up moment at this point P, pila ilang perpendicular distance of these three forces kung mag-intersect sila ana nga point. Di ba? Mahimong 0. Therefore, the moments of a body that is being subjected by the three forces will generate a zero moment from the point of intersection of these three forces, making it in equilibrium. Okay? Now, let's take this example problems to, I don't know, to apply the theorems of the two-force and three-force body. Okay. So we have here one end of a rod AB rests in the corner A. Okay, and the other end is attached to cord BD. If the rod supports a 40-pound load at its midpoint at C, find the reaction at A and the tension in the cord BD. Okay? So, where is our free body ani? The force system. It is the rod AB. Okay? So if a AB is our free body, we're going to detach this tension. Okay? This tension is considered a two-force body. Kung sa iyang line of action along the cable. Okay? How about ang rod AB? It is a three-force body because there is a reaction at A, a tension at B, and an applied load at C. So, pila ka buok force ang nag-act ani nga body? Tulo ka buok. Okay? Now, so at A, it was not identified that if this corner here is a sa tawag it is not sa tawag, pin connection no, or pin supported. However, it is resting along the X and Y axis. So pila ka buok ang ato ang normal force diri? Duha ka buok along X and along Y. Ang ato ang tension BD, it is always along the line of action ay along the cable. So that is the direction of our tension BD. Ang ato A, wala ta kabalo kung unsa iyang direction, no? But we know that it has a reaction along X and along Y, given that it is resting at this corner, okay, touching the X and Y surfaces along this corner. Okay, now, ang ato ang tension BD, we can resolve this, pwede ra gani dili, no? Nato ni siya makuan because The condition of a three-force body is that at a certain point, okay, the forces that is being applied to the free body, that is being applied with three forces, will intersect at a certain point. The applied force 40 pounds at C has a given direction. Ang atong pong tension at tension BD has also a direction. So, if we're going to extend its line of action, padulong din ha, okay, it will intersect at this point. Since this is a three-force body, meaning the third force that acts on the body will also intersect on that point. Asa man ang ikatulo? Kani sa atong reaction at A. Diba? So, gikan diri sa A, we can say that the line of action of our reaction at A is also along this direction. But we still do not know yet if it is going towards or going pana, no? Wala pa ta kabalo. But we know that, this is the line of action of our reaction at A. Okay? Now, kung saan man dayon nato ni siya, ma'am, kung makabalo ta sa atong line of actions sa ato ang forces, we can then draw a force polygon. Kung saan po si force polygon, ma'am? Okay. Wala na ako na-erase no from the previous class. Sige. Now, in order for us to determine kung pila ni siya no or unsa ni ang iyang angle nato dili, we need other mga dimensions. So to get this height, okay, from this point A at B, padulong din nga point kung asa nag-intersect ang atoang line of action of our reaction at A, we need this distance. So by ratio and proportion, this is 10 over 24 is equivalent to y over 12. Okay? Big triangle is equal to small triangle. So we can therefore get this as equal to 5. Okay? Now, we need this angle alpha to determine kung pila ang ato ang angle of inclination or the direction ani ato ang RA. Kaya ato ra manabalaan kani si tension BD wherein makuha man nato na siya ang angle no from this angle o ani na lang wala. Ang ato ang C vertical man. Kaya ma-plot nato in our force polygon. So tangent alpha is equal to 23 opposite over 12 adjacent. That is, this angle is equal to 62.447 degrees. Okay? So, in our force polygon, a force polygon is a force triangle or a polygon. Depende, no? That is also applicable to one or many forces. Okay? However, since three-force body man ang atong i-consider, so tulupod ka sides of the triangle ang atong ma-draw. Okay? So ideally it looks like the same sa katong atoang triangle method to determine the resultant, di ba? So kung makuha na to, ma-close na to ang atong force polygon, the body is said to be in equilibrium. Okay? Now, a force triangle is drawn as shown, and its interior angles are computed from the known direction of your forces. Using the law of sines, we write because the sides of the triangle now will serve as a representation of the magnitude of your forces. Now, si tension BD o si 40-pound force can be drawn directly because known man ang ilahang directions. In a head-to-tail manner, okay? Head-to-tail manner, adi si RA, padulong kung na siya dagto. Pila ni karon ang ilahang angle, no? Ilahang mga interior angles. Okay? Now, kana, nakuha na to 62.447. Kani nga angle, asa man po nato na siya makuha. If we get this angle, okay, sorry. Pwede na din siya, no? Since this is right triangle, vertically upright, ang ato ang 40 pound ng force, then 90, okay, minus kani equals kana lang nagbilig. Okay? Sunod. Kani, ang atong tension BD has a direction equal to phi. Okay? If that is phi, kani, phi sad na siya. Okay? So, para makuha na to na opposite, which is 10 over adjacent na 24, P is equal to 22.62 degrees. Okay? So, if that is P, kana, P gihapon. Kana, P po gihapon. Diba? So, 90 minus kani equals 67.38 degrees. Okay? Since nakuha man na to, kani si P, diha, sum up na to 85.067. I-check din na to if it will sum up to 180 degrees. To check if the interior angles na nakuha ninyo from the dimensions of the rod and our tension cord, PD, then correct, no? Ang ato nakuha ng mga angles. Sunod, since given na to is one side given and all of the interior angles are given by sine law, no? Ang sine law that is true to all sides, RA over sine of its opposite angle is equal to tension BD over sine of its opposite angle. The given force 40 over sine of its opposite angle. Pila ka bukang atong unknown? 1, 2. No? Magnitudes na lang. Okay? Okay, we already predicted asa ang atong line of action sa tuang reaction at A. Okay? So, by sine law, starting with this unknown, no? Para makuha nato si RA, cross multiply, then you'll get RA is equal to 37.06 pounds. So, yan direction, tara, no? Nakuha na to kaganina, 62.447. Okay? So, yun sa nato pag-identify, napadulog na siya dito from a head to tail manner, gikan sa tuang force dito no sa 40, when atong tension VD is going to ana pod no from at B. So, ma-predict na to in head to tail manner, ang head sa tuang last ng force na itong giplot, padulog po na balik dito sa tuang tail sa tuang first na force. So, that is the direction of our RA. Okay? So, force polygon, dito na ito makuha ang atuang direction. Okay, kabalo man sa line of action, but asa karon ang head o ang tail sa tuang reaction atin. Minhapod na siya na ito makita sa tuang force polygon. Okay, sunod, kani, no, by sine law, cross multiply, your tension VD is equal to 18.57 pounds. So, sa iyang direction, nakuha na ito kaganina, no? Anang angle. Okay, so we are now determine the reaction at A and the tension at B. Okay, so if you choose to solve it by summation amount and summing up forces along x with the result, no, you will arrive with the same answer. Okay, so but this is an alternative solution in order for you to give a prediction of the line of action of your forces. Given that if a body is in equilibrium, ang forces, there is a certain point mag-intersect sila. Okay? Thumbs up if nakakuha. Kasunod. Okay. So let's move on to our next problem. We have here rod AB is supported by a pin and a bracket at A and rests against a frictionless peg at C. Determine the reactions at A and C when a 170 Newton vertical force is applied at B. Okay, so pin connection at A and a peg no, resting here. So asa to ang direction ani? Ma-identify na to ang direction sa to ang reaction at C since it is a frictionless peg, it is always perpendicular to the surface. Okay? So for our free body diagram, ang ato ang force na 170 o ang ato ang reaction at C, okay, which is always perpendicular to the surface, ang ato ang reaction at A, which has its components AX and AY. Now, since known man ang ato ang direction of the applied force and the reaction at C, pangitaw na to ilahang point of intersection. Naa diha. Okay? This is perpendicular, so 90 degrees na siya. Kana vertical. So, ang reaction at A will also intersect at this point. No? Dinha, kung siya padulong. Okay? So, for your force polygon, no? Since ma-identify na ito, doon na sila mag-intersect at each other, we need these points, no? These distances, kung pila na sila, kaya makuha na to ang atuang direction of our reaction at A. Kaya ang atong makuha lang nga reaction is kanina sa C, kung kanino nga given na direction. So, hindi pa na to ma-plot ang atuang reaction, ang atong force polygon without this angle. Kaya makuha na to na siya. Now, okay? So this alpha angle is equal to opposite over adjacent. You know, opposite 300 over 160. So alpha is equal to 61.9275 degrees. Okay? So, kani, 90 degrees mo na din ha. Okay? Vertical man na tong force. This is 90 minus alpha equal to 28.052 0725 degrees. Okay? So if we need, naalala ka ni, no? Pila man dayon ang kana similar triangle. Since kana vertical, kana perpendicular diha, okay? This forms a 90 degrees diha. So this P is equal to this angle. Good, no? So pila man dayon ni siya. Okay? Kana, pila man na siya. That is 80 tangent of 28.075. 0725. Okay? Kay, gikan tira, this is in the midpoint, no? Kung nga ani, kana nga point, kung nga nasad. Okay? So 160 divided by 2, that is what 80 lang, no? So mo na siya. That's equal to 42.6667. Okay? Next. Kana 150 minus 42, that is 107.3. Okay? Sunod. This angle beta here, okay, since naman tay kani, no, over adjacent. So, angle beta is equal to 33.855 degrees. Opposite over adjacent. Kanasan siya. Okay, na triangle lang atong i-consider. Now, we can draw now our force polygon. Okay? So, tulo ka forces, tulo pod ka, tulo ka sides ang atong ma-draw. Now, ang ato ang given force na 170. Okay? Sunod, ang atong ma-plot kani si RC, that is P, no? From the horizontal. So, ma-draw po dato na siya. Okay? Sunod, ang atong RA, gikan diri, okay? Gikan diri, sorry, head to tail manner maday. Padulong po siya dito. Okay? So, that would be the direction of our reaction at A. Padulong dito. Ha? So, nasa sa second quadrant. Okay. Head to tail manner. Okay? Sunod. Nata isa ka side, unknown, ang duha ka side. And then, with these angles, makuha na to ang interior angle. Because known naman na to atong directions of our forces. Okay? So, if this angle is P, 28.0725, ana, 90 minus P, 61.9275. Okay? O, nakuha ang layup na itong ikabilang kasi. Sunod. Kani, angle, pila mo ni siya. Okay? So, if our RA is kanina 33.855 degrees from the horizontal, 90 minus beta is equal to 56.145 degrees. And 180 minus kanina minus kana equal to 61.9275. Okay? Next, by law of sine, ang atong given na nga side kani, no? That is equal to all sides equal to RA na to is equal to 170 sa yung direction nara, no? Kani ito nakuha nga delta. 33.855 degrees to the second quadrant. Sunod, kanina po, RC is equal to 160 newtons going 28.0725 degrees sa first quadrant. O ha? Asa mo lang inyong masayunan na solution? So there is another way, no? Okay, it is very important na you will encounter na ani nga mga problems, no, such that if you are if there is a composite body, okay, composite body meaning one or two bodies will be connected at a certain point, and you are to determine pila ka daghan imong unknowns, but you can eliminate the other nga mga forces if or the other unknowns if you know kung asa daan mo direct or asa ang direction daan sa imong reaction, no? Kaya instead of kwaon na to iyahang components, isa na lang kabuok. Okay? Now, for the frame and loading shown, okay, determine the reactions at A and at C. Okay? Parehani. There is a body at BCD, and another body. This is a pin connection at B. When you say it is pin connected, meaning there is a reaction at this point. Ano po yung reaction ani? Okay? Reaction code diri. Okay? Now, for your free body, since this is a two-force body, no? Okay? Ang atong AB is a two-force body. Nga naman, since this body, this whole composite body is in equilibrium, meaning their line of action will always be collinear with each other. Okay? So, collinear man sila by connecting this line A to B. Ang kanila to reaction at A and reaction at B will be on that direction. Okay? So, si B po, napo na sa diba? Okay? Now, considering our force ay this body, BCD now, it is a three-force body having a reaction at B, okay, and a reaction at C and an applied force at D. So, tulok yan kung kabuok. Okay? Kabalo man ta nga mo ni ang ato ang line of action of our reaction at A and our B, kani will be extending its line of actions, okay, from B to D, di na sila mag-intersect. Okay? So, kani po, ang reaction at C will also intersect at that point. Okay? Given naman, makuha man nato atong reaction at B, no? With the line of action sa ato ang two-force body AB. Okay? Now, ang ato RC, hinala nga direction. But we still do not know if ang ato ang reaction is going towards ba or away from this point of intersection. Same with your reaction at C. Now, 45 degrees na siya. Okay, similar angles, 45 degrees. So, kani, pila ni siya nga dimension. Okay? So, that dimension, since this is 10 inches, no? And then, yung opposite, kaning angle is 45 degrees, pila mo na siya. Tangent of 45 is equal to opposite over adjacent. So that is equal to 10 inch. Okay? 45 degrees, 10 of 10 ko na siya. Okay? Sunod. Kani, pila man ikaw karon? 6 inch. Okay? And that is 10. So, is equal to opposite over adjacent equal to 59.04 degree. Kani nga. Okay? So we now have the delta C and RA. Okay, but wala pa kabalo kung kabulong ba dito o kabulong ba dito. Okay, now, For your force polygon, you can draw the 30 pounds force directly, no, which is the, uh, vertical downwards. Sunod, ang ato ang RC. Okay? But in a head-to-tail manner, pwede ka magsugod kani or kana. Okay? So, our RA, given that its direction is wala ko internet. We, okay, it seems I was disconnected due to uh, low signal sa to ang ano, internet. Okay, so sakit ta. And end. Okay. No, no, determine na to ang atong point of intersection of all of these three forces na to. Okay? So, all right. So for our force polygon, no, we can draw vertically our applied force na 30 pounds with the given magnitude and the direction. And then for our reaction at A, okay, that is 45 degrees from the horizontal. Okay, that is our reaction at A. Next, in head-to-tail manner, our reaction at C, okay, padulong po doon sa mabalik sa itong first na force. Okay? Next, kani, na angle, since 45 degrees man eh, diba? Na 90, pila man tanan? 135 degrees. Okay? Next, this angle here is 59.04 degrees. So 90 minus that angle equal to 30.96 degrees. Okay? Kani, 180 minus these two angle, 14.04 degrees na lang. Okay? So by law of sines, okay, RA Ano naman tayo, one side known with given all interior angles, so makasign lot ta. Okay? Dili pwede ang cosine kay, no? Ang atong cosine, we need at least two sides. So, dili ta pwede maka-cosine since unknown man ang ato ang duha. So, start with, to get your RA, ang magnitude equal to 36.616 pounds. Kung sa ato ang direction, from the horizontal, 45 degrees towards the fourth quadrant. Ang atong RC, okay? Kuha na tayo ang direction. So, magnitude na lang atong kulang, 87.44 pounds. Sa yung direction, towards the second nga quadrant. That is 59.04 degrees. Kuha. Thumbs up if nakasunod. Alright. Bye. How about the others? Marga puno ga thumbs up. Murag 15 na to kabok ako na makita. Okay. Sige, anak gyud. Participate kay aron makita nga alive pa mo din ha, wala ta nga tulog ug naglaba ha. Okay. Sige. So, either kani nga solution ang inyong gamiton or pwede ra pod mag-sum up mo og moments. Okay? Now, let's have a seat work. Nakahatak na ba ko ang mga seat work sa mga class? Okay. Ha? Mag-seat work ka. But this time, isubmit ninyo tanan. No, wala na plus point. Kailangan mag-participate ng tanan. Hindi pwede na paturang gusto og plus point. So, dito na ko na ipasubmit sa to ang Google Classroom. Pero makita na ko ang submission sa tanan. Okay? So, for a while na. Okay, for 15 minutes, everyone, submit your submit this sa tuang Google Classroom. Okay, so ako sa buhatan ang kuan para makasubmit mo dito. Okay, so for 15 minutes lang ha, time is 9:53, so mauman mo by 9:13. So we still have time to solve na dayon siya nga problem. Okay, naraman na makita naman ninyo din na so to follow ra niya to ang classwork so that you can submit. Tanan ha, walay pili. This will be graded as your seat work. Yes, Miss Ira.
Excuse me, ma'am, ay kanang pwede mi magamit atong summation lang na solution, ma'am?
Sa
Kaning
Jato.
pwede mi magamit atong summation na solution, ma'am? Dili lang kadtong head to
Magamit.
tail.
Pwede ra.
Okay, thank you,
Pwede
ma'am.
ra. Walay problema. This is sige, maghatag ko og clue ha. Kani is a two-force body. Okay? So the idea is that you will know now the direction. So ma-identify ninyo pila ang moment from this point to that point, and then kung magsabak ka og moment, no, to solve this, pwede ra. Sige. Inana lang po ang atong solution.